computer Mr. Computer Doctor, everybody let me does get flatter. Computer Mr. Computer Doctor, you put it all on.
Hello, beautiful humans of the internet. Yes, hello to my fellow humans. Well, my fellow cyborgs, typically. That's a little bit more correct. Cyborgs, humans, robots, and eventually, when this signal reaches you, extraterrestrials. Please go gentle on us. We're a young species. We don't know what we're doing yet. Anyway, here we are today with my favorite robotic plushie Gopherbot here at La Pipa in beautiful Asturias, northern Spain, where I've got some fun stuff for you today. Let's put the mask down. Yes, Gopherbot is gotten the second vaccine. I haven't even gotten my first. Something to do with essential workers. I don't know. Go figure. So yeah, it's been a really cool week. Lots of stuff happening out in the real world. So one of the cool things that we've been seeing is since our release of the last Tiny Go, we've just had an enormous amount of contributions and also a lot of really cool, interesting stuff that we ourselves have been planning on implementing that is finally coming to fruition. So let's take a little look and see this week of some of what has been our activity. So the dev branch is where everything in TinyGo is generally happening. And we are already 46 commits ahead of the release, which only took place 20 days ago. So that is more than 2 commits per day on average, and with lots more actually still to be merged. Let's take a look and see what some of the latest and greatest coolness is. So let's go back in time, going back in time to last week where we brought in some of the code that was contributed by Sago35 with some of the performance enhancements for our SPY interface, which we used to test by running the bouncing ball demo on the Pi portal, if you remember that. That was pretty cool. But since then, there have been lots of activity happening. First of all, Ken Bell, amazing contributions coming in from Ken Bell specific to the STM32. So what is the STM32? So STM32 from ST Micro is a microcontroller family which is generally used for a lot of industrial applications. You know, they're one of the world's largest manufacturers, and the famous Blue Pill, which was, I think, the first $1 microcontroller that was a member of the ARM Cortex licensees. So they have a lot of different boards in their different families, and Ken has been extremely busy adding support for really each of the main product lines, both of their older ones and then also of their newer F7, L5, and L4s. So that's pretty exciting because a lot of interesting industrial controllers, 3D printers, battery systems that are used in electric vehicles. More on that, hopefully, when the non-disclosures are no longer in force. Oh. Anyway, what was I saying? Yes, STM32. So Ken has been really busy adding support for the STM32. And one of the things that he added, which was especially useful, I'm sure to you, our beautiful community of developers of embedded systems, is the I2C implementation for the F7, L5, and L4. So if you recall, the I2C interface is what we use for the all-important screens, for example, and sensors. For example, the screen that is on my little drum controller. So pretty major contribution there. You can't do anything that's really important and interesting in the world if you don't have I2C support. So thank you very much, Ken. That's an amazing, the really prolific contributions. I mean, look out. Keep going. This is awesome. Now, on the compiler side, Ika has been working really for months on adding some capabilities to TinyGo. And one of them has been an accelerated compiler by being able to compile in parallel. So you may have noticed if you use TinyGo that it compiles a lot more slowly than the regular Go compiler. Well, the Go compiler, the main Go implementation, is optimized for speed of compilation, but not really optimized for size of executable, whereas TinyGo is very much optimized for size of executable, but performance of the compiler is not at the same speed. Also, we do some work that the main Go compiler does not have to do, which is compiling the C code in, using LLVM. We are basically turning our code into a much tighter, much more challenging to link than the linker that's built into the regular Go compiler. So, that's a lot of the time that's spent. Anyway, so Ike has been working on some particular features. Oh, thank you. Yes, a glass of water is always good. So Ike has been working on some features specific to the compiler, and there's a pull request that's about to land that's actually one of our most long-awaited features. It is JSON support. Yes, JSON. So the JavaScript object representation of JSON has become the standard that's used by communication for machine-to-machine protocols like MQTT. It is very typical to use JSON over MQTT. If you're using REST to call web servers, it is very typical to use JSON payloads, both sending and also receiving. If you're calling APIs from Google, from Amazon, from Microsoft, you're almost guaranteed to be receiving JSON back. So we do not yet have full JSON support. Okay, to be fair, it is actually substantial effort because the JSON package that's part of the Go standard library, encoding JSON, uses very intimately reflection. So what is reflection, you may wonder? So reflection is the ability for code to look at itself, and in order to make determinations that normally are impossible at compile time and only at runtime. So what does that actually mean? Well, let's take a look here. So if we look at reflection and JSON, so and we look at images, because an image search almost always, this is totally random. I haven't even tried to do this yet. Let's see. This is, let's look at Go reflection. Golang reflection. And let's see if we get a good diagram. Oh yeah, here we go. This is actually pretty good. So, can we look at this enlarged in C2? I don't know whose website this is. I hope I don't get spammed by advertising, but let's keep going. So that diagram right there is basically kind of shows this idea where, and when we compile a Go program, it's a little different than when we are executing code written in a dynamic language like Python or JavaScript. So in Python, the code that is running can always look at itself because it's compiled right then, or not compiled, it's actually executed and interpreted in its text form when you are running the code. That, of course, has benefits as far as things that are called metaprogramming, where code that writes code, but it has drawbacks because it prevents, generally speaking, typing of things, which is requiring that an apple actually be an apple and not something similar to it like a pear or cherry or pomegranate. And so as a result, programs that are written in compiled languages are a lot stricter. But without this ability to look at themselves, they can't perform this important function known as reflection. So reflection is where, when we're running at, that program is actually executing, it can look at some piece of the code, like a struct in the Go language, and it can make determinations about whether the types of those things dynamically while the code is executing, because the interface allows us to call it, but it doesn't necessarily tell us all its details. So when this comes into play is when we're using JSON in Go. If we go to JSON Golang, almost for sure we'll find the awesome website Go by Example. And so we can see kind of here is a case where we have a struct, which, by the way, this is not yet fully implemented in the TinyGo implementation, but let's just understand what it is first. So if we have this struct, and it's a simple type, it's got first a page, which is an integer, and then it's got fruits, which is a slice of strings. Okay, so here's this type, and in JSON, we would typically see this sort of thing when we retrieve calling an API. So let's say we're going to call the fruit API here, and it's going to return all of the fruit that's available for us to buy at the fruit stand down the street. So it returns this data in the form of JSON. So we know the structure of it because this is already predefined. So how do we take this text, this information that's coming in, this JSON, and how do we put it in to the struct in our Go program so that we can then just use it as a strongly typed piece of information and move it around, between the different pieces of software that we're going to execute, whether they're Go routines or just other code that we've written. So the way that this happens is by using this reflection. So the reflection is going to take, and it knows that in our JSON there's a page and that there are fruits, right? And we saw this here because we saw that actually there's a struct. Here's one right here. We see that it's got a first value, which is page, which is an integer, and then it's got something called fruits, which is a JavaScript JSON array consisting of strings. And so in our Go code, thanks to the encoding JSON package, which is part of the Go standard library, we have the ability to both marshal, which says take this struct and put it into JSON, and then we also have the ability to unmarshal, which is the opposite direction. It says take this JSON and unload it from its text and put it into a struct. That way our Go code can now deal with it as a struct of a particular type. All right, so now that we have a little bit of an idea about what is reflection and how it works in Go, specifically in JSON support, now and only now can we really appreciate how remarkable this particular achievement is, which is this initial JSON support for TinyGo. So, so this only adds partial support, does not yet actually work to marshal and unmarshal structs. But we can take a look by looking at the files changed, and we can see what it currently does support. And in our tests we have here, one of the tests that Ike wrote is this test here, which you can see it's importing encoding JSON, which is just the normal Go standard package. And then our main program is just going to encode. So encode takes some value, just any value at all, just it takes a raw interface type. That way you can see that it's actually using the reflection, right? Because interface is this sort of base type for everything. And so interface, if we do not actually know the type, if we want to say be able to take any type, we could pass it here as an interface struct. And so we marshal that into our buffer, and then we return that in the form of a string. Okay, so you can see we're not actually yet able to marshal an entire struct. We're only using simple types here. So Ike's code here is encoding an integer, a float64, yes, the Epiphemus pi, another string, and then a slice of strings. So I would assume from this test that as of this moment, those are the only types that you actually can successfully marshal. And let's see if there's an unmarshal test. I don't see any unmarshal tests, so I have a funny feeling unmarshaling maybe doesn't work yet. Um, but we need marshaling probably first because we're going to need to construct a payload to send to some service for them to then want to unmarshal it, where we would then take that result and put it into a Go struct and do something. So this is actually a major accomplishment because it is able to incorporate one of the most powerful and frankly memory expensive parts of the Go programming language, which is reflection. I mean, general reflection is to be avoided whenever you can. Especially with strongly typed languages, we don't really need to use reflection, right? We already know the type of things until we have to integrate with outside systems where these types at runtime, could have some variations or, either by design or unintentional variations, just APIs that, may or may not work entirely as expected or may have issues or errors in them. I mean, we cannot prevent errors in software. That's impossible. What we can do, right, is that we can, when errors occur, decide, are we going to handle them? That was one of my favorite things about Go. Like, you don't have exception handling in Go. Well, what do you mean? Like, we don't catch exceptions in Go. We handle errors. Okay? What does that mean? We'll talk about that in a future show because that's about enough of a code rant for the moment. So, see a couple of people showing up in the stream chat here on Twitchlandia. That's really awesome. Hello, Escarolo. Hello, Poo-Poo the Gorilla. Is there technical reasons why struct can't be added as well? Or is that just the next step? That's just the next step. First the simple types, and then from there, structs are composed of those types. So I fully expect that that will be coming next, basically as soon as this pull request lands. And now, there are some drawbacks. Okay, what are these drawbacks? Well, by using reflection, just in general, in TinyGo, we have had some support for reflection for a while. Not full support, but some limited support. But it radically increases the memory footprint of your TinyGo program. I believe that the code that was added for just this very simple demo on a ARM Cortex M4 or whatever, I think it increased the memory footprint by 50K or something. So, in TinyGo terms, that's a very large memory increase. So, anyway, though, it's very exciting. It's one of the key things that we need in order to support some of the standard encryption packages so that we can do things like create JWTs for authentication to various services. So this was a really key step forward and pretty exciting stuff. Good job, Ike. I'm going to merge that real soon. I just got to keep looking at it a bit more because it's pretty complex. So one of the things I wanted to do this week is I wanted to take a look at some of the pull requests that we have outstanding in the drivers repo. So our TinyGo drivers repo is a separate repository that we have specifically to contain the drivers for TinyGo programs that run on microcontrollers to be able to integrate with sensors, with little displays, with GPSs, basically with, and I think we have at present, let's take a look at the count. We have support for 56 different devices at present. So temperature sensors, accelerometers of many different kinds, motor drivers for when you want to try to, drive things around, or stepper motors. So there's a couple of pull requests that have been outstanding for a little while, and been meaning to get to those. And so let's take a look at this one here. So Elliot's, who is a first-time contributor, all the way back in November. So you could see I'm really, really behind in some of these pull request reviews. Sorry about that, but let's do it now. So let's take a look here. So this is adding support for a DRV8838, which is a kind of pulse width modulation device. Let's take a look at one. So it's generally used for motor controllers, and you can see here pretty good example of that's basically used for brushed motor controllers generally, which are the kind that you would use for things like cars, radio control cars or tanks. Generally, brushless motors are more commonly used for drones. But anyway, it's a motor controller that is very commonly used. It's got a relatively simple circuitry layout, as you can tell from these pictures, so it's not too difficult to incorporate into a device you're trying to drive around. So this is actually a very cool pull request because Elliot's has included the truth table for the device logic for the DRV 8837 and 8838. And so they didn't actually have both of these devices. So they originally in the first pull request added both, but I requested that they please remove the one that they were not able to test, just in case hopefully somebody who actually has that other device can test it out and we can bring back in that code. But it seems like a bad idea to, especially with devices, seems like a very bad idea to commit code to the repository to, in theory, control these devices when you have not tested this device and neither has the author of the code for that device. I mean, no, that's not really a good plan. So didn't do that. Instead, it's just for the DRV 8838. So we can see that it is following our general patterns that we've established for the drivers repo, that each one of the sub-packages, well, maybe we should take a look at that here, but each one of the sub-packages contains the driver just for that name. So in this case, the DRV 8838, and it will contain a function called something like new device, which will in fact, or new, I think it's generally called new device, and that's going to return a new motor device driver for this particular, in this case, motor controller. Then it will always have a configure function. So configure does what you might anticipate from being named configure. It takes this particular device and configures it so it's ready to use. So in this case, we can see one of the things it does is it takes this pin that was passed in for phase and it turns it into an output pin. And then if there's no sleep, or if there is a sleep pin, then it also configures that. So there's two pins that are used for controlling that. And then we have forward, backwards commands. That's basically for turning the motor on to go forward or to go backward. And then enabling the motor's speed. So basically by using pulse width modulation, or PWM, the control of a motor's speed can be set without an actual analog circuit, not without a specific voltage, because of pulse width modulation's ability. Let's take a look at that for a second. So what is pulse width modulation? It's basically turning things on and off very quickly in a way that it makes it act like it's sending a signal of a certain strength, known as the duty cycle, but instead of it actually being an analog signal where it's increasing gradually based on a voltage, instead it turns it on and off very quickly. So the net effect is to have a certain strength of that signal, which is generally commonly used for things like controlling motors or for controlling LEDs, right? So a lot of LEDs we control with pulse width modulation because, like for example, RGB LEDs, if we set the red, the green, and the blue to different strengths, then we can control what color that LED emits. So just kind of give you some idea of what the purpose of this is. All right, so so Elliot's has added a Elliot's did not add a, oh, sorry, let's go back here. So Elliot's did not add a smoke test to this particular pull request. So in our driver's repo, a lot of the code does not have an easy way to be tested live because not everyone has all those devices. So we have different layers of testing that we have put in place. So one of the tests that we do is some of the code, mostly I2C devices, have in fact tests that we've written now, thanks to Raj Peep, who added the first pull request with the quick test package. So basically this is an example of the ADT 7410, which is an I2C device, and it has a very simplistic test to just see if, in fact, the driver returns the expected values. So it's not really calling any hardware, right? So it's just a test of, is the driver code correct, but not necessarily does it do the thing that we expect, right? So then another level of testing that we have in this repo is what we call our smoke tests. So the smoke test is a famous term from, I guess, the old days of probably of steam engines, I would guess, right? Like they would fire up the boiler, and if smoke came out, they would turn it off. That's way before my time. I know about it from electronics and aerospace, where you would turn on the electronic device, and if it started having smoke come out of it, you turned it off really quickly, and probably don't fly in the airplane that day. Yeah. So anyway, in software, smoke tests are usually used for a kind of test that is not deep or profound, really superficial kind of test. In our case, for the TinyGo drivers repo, all we do is literally try to build that driver on a couple of different of the supported hardware platforms. If it builds successfully, then we count it as passing the smoke test. So it's just to make sure that there's no incompatibilities between either that driver or alternately some sort of incompatibility with TinyGo itself. So when the smoke tests in the driver's repo execute, they actually execute against the latest build of TinyGo, which has been built by CircleCI. So CircleCI is the continuous integration service that we use. Let's bring up the little homepage. Shout out to CircleCI. Please feel free to sponsor us and give us some free GPU testing. We'll get to that. Anyway, CircleCI is doing the builds for TinyGo's open source project. And when it does its build, it on the main TinyGo repo, let's go take a look at that really quick just so you see how this all ties together, because it's pretty well done. A lot of people have worked on this. So in TinyGo itself, the compiler is changed. We run a whole bunch of tests that go through CircleCI. And one of those tests is that it actually, at the end of the test, it goes and it takes and it builds a Docker composer, or Docker container on Docker Hub. So on Docker Hub, we have repositories for our main Docker containers, of which we have really two different containers that are important. So the first one is the TinyGo release container. So when you go and you use the TinyGo release version, this is where that container comes from. and it does not include all of the debug and development things. It's designed to be really a much smaller container. And let's take a look and see if we can see the size here. So it's 300 megabytes. So not too terribly large. So we also have, in addition to this, we have the TinyGo dev container. Let's see if I can go back to my... So the TinyGo dev container is built every time we have a commit to the TinyGo project itself. And whenever the development branch is successfully built, as a part of that, Docker Hub will build a version of that particular dev build in the form of a Docker container that you can then download and run. So if you want to test the latest build of TinyGo and you want to do so without having to actually install anything on your machine, this is one way to do it. And that, in fact, is how we're doing it in the TinyGo drivers repo, is whenever we run the tests here, we pull down and we use the latest TinyGo development image. That way, if there's any sort of incompatibilities that pop up in TinyGo itself, we'll know pretty quickly because all of the tests in the TinyGo drivers repo will start to fail. So the idea here is defense in depth, but applied, I guess in this case, it's not security, it's software reliability, and the enemy is us. We are the enemy ourselves. I've seen the enemy and it is us, as the famous cartoon once said. So anyway, let's go back to this new pull request is really cool, but he did not actually add a smoke test. And now I'm a little embarrassed because the last time I communicated with Elliot's was November 16th when I asked for some sort of change. And since then, I have not responded to the last message on November 16th. So I guess now I have to decide, what should I do? Should I add a smoke test myself and then merge it? Should I ask this contributor to, after all this time, go back to it and add a smoke test? It's a little tricky. Here's why. So Elliot's already has put some time into making this contribution. I wonder if they will be happy that some extra work has been done to it, or if they would prefer to do that work themselves. Now, because it's so long after the fact, it's a little embarrassing for me to ask. So, however, just because of politeness in open source development, I feel compelled to at least ask, would they like to do it, or would they prefer that I do it? And so let's just make a comment here, sorry it has been so long to review this. So that right there is just, let's start out with, I notice that this PR needs a smoke test. Let's see, needs a smoke test added. Would you like to do it? Would you like to do it? Or would you prefer that I do so? That way we can give this person, the option. And a thank you. So we should at least give them a chance. If they want to finish it out, just have that sense of completion, then cool. If not, then I'll be happy to do it. For a number of reasons, not the least of which is it's been incredibly long. So, my bad. Got to be a little bit more prompt about reviewing pull requests, just because it sort of takes the momentum away, I think, from potential contributors. So, anyway, this is why we have a number of members of the TinyGo organization, but this one's on me. So sorry about that. All right, but let's take a look at some of the other. There are some other pull requests in here. Um, Nurzal, who is actually the author of the TinyGo book that's coming out on Pact Publishing. First TinyGo book, kind of exciting. I thought it would be me, but I was very slow. I am very slow on writing my book, and they have been very fast at writing theirs, in fact. So what is this? So this is an IC, the MAX 7219. And this is an IC that is very typically used for controlling segmented LEDs, like, you know, the famous old school segmented displays like AliExpress has got so many of. I think these things are kind of an awesome retro look, but also they are much simpler to control generally. So, all right, cool. Let's take a look and see what's going on in this code. So I know there were a bunch of changes made. Conejo Ninja asked for some changes. A bunch came in. Basically to the purpose of these changes that he was asking for were specifically to try to make the API a little bit more consistent, and then also mentioning a few things that we have in our contributors guidelines. This was all the way back in January. So changes were made. I made a couple of comments. So it turns out that this IC is used for many different kinds of displays. So having kind of a simple single API is not quite so easy to be able to do. I see that there is also a merge conflict here with the makefile. That's probably on the smoke test. Let's go take a look and see what's in here. So let's see. First of all, whoops, VS Code file should have not been committed. Probably, I think we have a Git. I think we have a file in this repo that should have git ignore file that should have not included that file, but apparently no. We need to actually add that to the dev branch so it git ignores VS Code file. So, okay, well, don't worry about that. That's a small problem. Makefile. This is where the merge conflict is, probably because of changes that came in subsequently. A change to the README, which then adds the listing of this device to the list of supported devices. Okay, very good. An example. Yeah, so this is also kind of key. That was another thing that was missing from the other pull request. I guess I should probably mention that as well. Well, we'll see if they respond first. So generally speaking, in our examples directory of the drivers repo, we have examples that have been created for each of the different devices. That way, if you have one of these devices, you can go and take a look and see, oh, here's some code that actually shows you an example of how to use it. That's kind of key, right? So this is good. It's kind of a complex example only because it turns out that the segmented displays have a lot of variation in them. So here's the driver itself. It uses the SPI interface, and so that's interesting. I did not realize that this particular controller was a SPI controller, so that's very cool to use. I guess that's one option. This MAX 7219 could probably be used to control a very large number of connected LEDs, like a stadium-style display. So that would be kind of neat. And yes, so here we see the functions that have a capital letter in the Go programming language are exported. The ones without in the lowercase are not exported, so you cannot call them from outside. So we see here that the exported functions all have comments. That's very good. And then a separate list of registers. So, I mean, I would say that this pull request is quite good, that really the only thing that needs to be done that I could see was to deal with the merge conflict, also squashing it. There's 14 commits in here to do one thing, so generally I would squash them together, and then also at that time resolve the merge conflict. So I'm not sure if I can do that with the GitHub web interface. I haven't used that web interface in quite a while. So I'm not too sure that I want to try it because I have a bad feeling that I will resolve the conflict. But then, well, let's see what options it gives me. Because if I resolve the conflict and then it merges all 14 commits, that would not be good. That's not what I would want. So instead of doing that, what I would normally do is, again, the GitHub command line instructions are quite good for us to be able to follow. So let's go ahead and go over to copying that first line, which is going to check out a new branch that we're going to put his code into that's based on the dev branch. So if we go back to the my terminal window here, and I'm in the dev branch, so I'm going to git pull rebase origin dev, one of my favorite commands. So that pulls in the latest changes and it brings them into my current working branch, which is dev, but without a separate merge commit, right? Okay, so now we can go ahead and git checkout -b for the new branch to check out the Nirzal device forks, or Nirzal device / max 7219 branch, better said. Okay, so now we got that. And then we want to pull that into this branch, but if you recall, instead of using just git pull, we want to use git pull rebase, so that once again we don't end up with a separate pull merge commit rather. And it's probably going to fail. Yes. Now here's why. One of the reasons that we could see is that I have a .vs code settings JSON file because I have this open in my editor. Or maybe I just have one that's already saved. So, I'm going to remove that file because I don't actually need it. And then I'm going to bring it in by trying that operation again. This time it will succeed with that, but now it will hit the original merge conflict that I expected, which is the one that we saw here in the make file, right? So we can see here, yes, we have a merge conflict in the make file. So let's go and take a look and see what that actually is. So I'm going to bring up my editor, Visual Studio Code, and sure, okay. Let's go see if we can find in our make file the merge conflict, and here it is right here. We see that the problem is that there's a section in our make file that says to not run the regular Go unit tests on these sub packages. The reason why we have this is that not all of the sub packages actually have Go style tests. They all have smoke tests, but they don't all have Go style tests. Part of that is because we are adding interfaces to the drivers package to make it a little more testable. I actually have another pull request from Ika in drivers that we'll take a look at right after we finish this. So let's take a look, and we see that there's actually been two different drivers that were added. One of them, or since then, one is this Max 72XX, right? If you recall, that's what we're trying to add now. The other one was a keypad that was added by the same contributor right beforehand. So we see that we actually have this merge conflict because they're both conflicting in the same line of code, and Git was not able to figure out what to do about it. So if we say accept both changes, let's find out what it does. Well, it just puts both lines in, and that's not what we want at all. What we actually want is we want this line, since it came in first, to be in front of the other one, and then edit this line out. So how am I just editing this code? Well, Git just works with text, and so you can use the cute little buttons and things in your IDE or your editor to resolve these merge conflicts. Or you can just go in with your text editor and hack them out, right? Because either way, we're going to have to do the same thing at the end, which is if we go over to my terminal, lost the window. Make this big again, and then go back to my terminal. Here we go. So Git actually told us in the message it displayed what to do about it. Okay, so if we read the output in here, we see, first of all, there was a merge conflict. So once we fix it, then resolve all conflicts manually, and then mark them as resolved by using git add or remove, and then the conflicted file. So in this case, we say, if I say git status, it will show us that one file, the make file, that's both been modified. So if I say git add make file, now I can follow the second part of this, which is git rebase continue. It says, I've made the change that was needed, and now I can just continue rebasing, and now we're done. Okay, so where are we? Git status. Okay, all the changes worked, and we seem like we're good. So if I were to merge this pull request now into the dev branch, the only thing is, remember, there were a lot of commits here. Like, he had way too many. So what I would really rather do is squash them all together into a single set of commits, or single commit rather, because there's just so many of them in there that it's just not really part of the work that we want to do. But that's not quite as easy to do now, is it? Because I have merged in that dev branch. So usually I would use a command called git rebase in order to do this squashing. So that's probably what we want to do here as well, because you can see he's got many, 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 many commits in this branch that we're in here, because we're up here, right? This is the this is not this pin example he removed. Basically all of his most recent commits except for this one that got merged in. So we're going to need to rebase how many commits? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26 different commits. In other words, we're going to rewrite history on the last 26. All right. So we said git rebase -i head tilde 26. In other words, starting with the head and going back 26 commits, let's use the git rebase interactive command to go and rewrite history. All right, so where to begin? So what happens when we use the git rebase -i is it brings up our currently chosen and configured text editor for Git, and then it brings up a text window with all of those commits listed in reverse order. Okay, so normally when we look at our Git log, we see from oldest to newest, going backwards in history. Well, in this case, we see that we're actually going forward. We're going from the oldest to the newest. And the reason is that what we're going to do is we're going to actually, this first word here tells Git Rebase Interactive what to do with this particular commit. So we have a few different options, and it lists them down here at the bottom of our text editor. P, which is pick. So that's just use the commit as it is, let it go through. R is reword. that says, let's use that commit, but change the commit message. E is edit, like stop here and actually, we have to change some code somehow. I generally would not do that. Seems like a bad idea. Squash is use this commit but merge into the previous commit. I used to do this a lot until I found out about fixup. So fixup is the same as squash, but it discards the commit log message. So if I want to just take a bunch of commits and put them all into a single commit with one message, fixup is a great thing for you. Then we have exec, which that's also one of these, like, I guess if you ran some generator or something, like, I'm not really sure where that's a very good idea to run a command in the middle of this rebase operation. And then drop, which is, I just want to get rid of this commit entirely. If you accidentally commit something to a repository and you want to get rid of that commit forever and ever so it's gone, you drop it and then you git push forcing it to that branch and it will be gone. So that's a tool of great sharpness and power. You must be careful. All right, as is this operation I am performing now. So let's go through and see if we can sort of decipher which ones of these that are the commits. And I might need to cheat and go back and look because it's a little hard to tell all the names of them just from their names. But if we go back and we go, because remember it's going to be in order from, should be starting from oldest to newest. So the first one would be add max 7219 driver. And so we see that, yes, here is that first commit that we're going to want to use. So we want to use this commit, but we want to reword it, right? So let's choose, I believe it's R, or I believe it was R. Use commit, but reword. Okay, very good. So that's the first one. So let's go to the next commit, which is going to be removed unused pins. So removed unused pins, we want to use an F for fix up, meaning we want to take this commit and use it and just squash it into the previous commit, but get rid of its message. All right. Next one, clean up. Same thing here. We want to fix that up. Add example. Once again, here we go. If you're not sure if it's the right commit, you can actually look at the commit SHA or hash, which is a unique algorithmically defined or algorithmically derived. That was the word I was looking for. It's derived via algorithm, so it's something that is uniquely identifying this particular commit and that we can count on. So we see it's 55507CF. And that was the one that we just got right here. So now the next commit, 59D2-4DE. And we see that that would be a different commit, actually. That the one that, here we go, yep, that's it, 4DE. So once again, fix that up. Here's another one, CCA. That's the next one. It's a lot easier to do this if you just use the GitHub web interface, but because I also needed to fix a merge conflict, so I needed to do it this way. So then we got this D59B, which we want to fix up. Then remove VS Code settings. Yeah, whoops, on that one. 0E. Oh, but also update number of supported devices first. So let's fix that up. Remove VS Code settings. Yep, fix that up. Keep going. Add package to make file and fix tests. We're going to fix those up. Isn't this fun? So let's see what else we got. Yes, change order of parameters, remove interface. That's this one. So we're going to fix that up. Now we're getting into some other people's commits, right? So we don't want to do anything with these. We can just pick. Just use the commit. Keep it in there, do nothing. All right, so what else are we looking for here? change order parameters 042D. Then here's one of those merge commits I was referring to. Why I use rebase is this is a merge commit that would be added if I hadn't used rebase, sort of yet another thing to remove. B4, where is that one? Not seeing that commit in this list. I may not be able to remove that one. Because I'm not seeing that actually. I may not be able to remove that commit. That's a bummer. Well, let's just keep going. Then we have fix broken MD5 lines. That's this here. So we're gonna. So we can't just fix up here because it will bring it in to the previous commit, right? Or can we? So it turns out that you do not need to keep this order. You don't need to keep this order. You do not need to keep the same order, but if you change the order in which the commits in your rebase operation take place, you may end up with unforeseen conflicts because it turns out yet a different commit than you expected is also changing that same line of code. So instead of fix up, I think we're going to have to, I'd like to go and look and, let's go look and see what it actually changed before we commit. That one commit actually, of course it changed several files. So it's not quite so simple as all that. I guess we're going to have to just, which operation should I choose? I think I want to, probably I'm not going to be able to get rid of it quite so easily. Dang, let me go look again here. Let me look one more time to see if maybe it changes. What does it do? Oh, I see, it adds a file. Wait, what does this have to do with this? This is from a different thing that I think they are working on. And probably that's what the next commit was, to remove the sample, remove a sample that was not part of that, probably. Let's see. Yeah, that removes that. So, okay. So really, once we squash it in, the only thing that's going to be changed is the makefile. So, are there any other files that have changed the makefile? Yes, because the subsequent pick or commit here changed the makefile to add the smoke test for that driver. So, but that's subsequent to this. So I think that if we were to take these two commits here and we were to put them after these commits here, and we were to, I guess, fix them up by just glomming them in with those other commits. And I got rid of this, so I can remove this line here. Let's see. Fix broken MD4 lines, done. Remove pin example. I need to remove this here as well. Okay. So let's take a look before we actually save this, which will go and perform the operation in our little Git surgery here. So we are rewording the message of the first commit in this sequence, which was adding the max 7219 driver. Okay. And then we are fixing up all of the other commits in there all the way through to the last one, which was removed pin example, which is this last one. And there are 14 commits plus a third merge commit, so we should have 13 lines here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, looking good. So when I say reword, what's going to happen is it's going to pop up this editor again, but giving me the chance to change the actual commit message. So do I want to save? Yes. So now you see it pops up the editor again. And so this time I'm going to say Mac7219 colon add driver support. You know, so many commits to just add driver support. Control X, yes. And so now we, looks like we ran into a problem rebasing. Okay, which was our problem? So we see it was a conflict in the merge file. Ah, yes, that was that same conflict we were trying to resolve before. Now it's come back again because we had to try the merge then. So let's go back to the make file. And we see, this was actually a different merge conflict. This one is because there was a test added for another device, which was the DHT. So the current change basically did nothing or brought that in, and then the previous change looks like it added this. So let's go ahead and say accept incoming change, because that's what's going to, because the DHT is not in here anywhere else, is it? No. So we're going to need to say accept incoming change, or we're going to lose that test. Okay. So that should be good. So now let's go back to our rebase operation. And now if we say git add makefile, because that was the file which had the conflict. And then we say git rebase continue. Then that continues. Now we're ready to actually try, and you see that this is a combination of 12 commits, so it tried to give us a chance if we want to go in and, you know, do some major massage of the commit message. I was happy with the commit message I chose before, so Control X, and what happened now? It looks like we got another merge conflict. This time is in the README. Ah, yes. So they probably both added their devices to the README in the list of supported devices. Ah, yes. Because we have now a new one added to this list. I don't think this count is even right at all, is it? It says 55, but didn't we determine previously that actually as of right now in the driver's dev branch that we have a list of 57 or something? 57. And so this is going back to 55. So that for sure is not right. We definitely want to say 57 because we know that count is correct. So we can hack out this little bit of text. Actually, since it added a new one, it probably should be 58, right? Because we have the new device that was just added, which was this display driver. And that was also, so actually we need both changes here. And then that looks like we've got everything. Okay. So let's just make sure we got all of our merge conflicts. And yep, so far so good. Going back. And so if we git add readme and we git rebase continue, so add missing new drivers since last release, sure. And we have one more merge conflict. This time it is in the makefile again. Let's go take a look at that. This is what happens when you have long-running commit branches and that you have not merged or rebased rather, the dev branch into your branch frequently enough to pick up all these other changes. All right, so we have, in this case, we need, let's see. We have a bunch of changes. What to do? Well, actually, they really are in two different categories here. One is that he added this new test, so we want to accept current change because we don't want to lose the smoke test for the new device that was just added. And then here we have a classic case of where there's actually two different devices, same as what we did before. There's two different devices that were added at the end of this line. And since the DHT was added first, I think, we'll just put that in. And then hack out the text parts of this. Just to make it go away. Same with this. Okay. And so that should now be correct. And so one way we can test that is we can actually run the smoke tests. So if I go over here, first of all, let's make sure that we've, if I say git diff, so I can see the changes I just made to the make file. And yes, that looks good. I've got both of those changes in there. So now if I say make smoke test, then that should run the smoke tests for all of the current devices, and we'll know if it failed very quickly just because it'll hit an error. Actually, it's probably already fine because the make file did not have any errors in it that were added by, some garbage that was left behind from this rebase and merge conflict. So the moral of the story is it's definitely a lot better if you rebase the dev branch into your feature branch more frequently than not, because that will help you avoid what we just had to deal with, which was, basically a whole bunch of merge conflicts, all of which were very small and easily resolved, but each one of which that required a little extra tweaking. And that's actually how Nurzal ended up probably with so many commits, and some of which were just trying to resolve conflicts with previous commits. This is a very common problem you run into if you're trying to contribute to a very active project. Keeping your code caught up with other people's changes, that if there are files, like in this case the make file or the readme, where everybody's making changes to the same file, what do you expect? You can only do so much, right? So I just want to make sure that these changes are good. Then we will merge them in, and then we can go on to something else I wanted to talk about today. I just want to make sure that these tests pass. It's very tempting to just say, oh, yeah, it looks good, let's just merge it. But after all the time we've just spent sort of extricating the rat's nest of commits, the spider web, code weaving, that's how I think of it. It's like, a Gordian knot of code, except you can't just cut through it, unfortunately. But this is a good thing. What do I mean? If you have a really active project with lots of contributors, and you have the problem that you have to work on helping your contributors get their code into your project, that is a great problem to have. You wish to have those problems. Usually it's like, hello, anybody out there? Hello? Hello, is this thing on? Hello? Well, anyway, all right. So the test passed, we look good. So I think we just have to add the makefile. So git add makefile, and then we git rebase continue, and hopefully we are now done. Nope, just one more. Just one more. The README, of course, the README. So probably because of a similar problem as before, that there was new devices added subsequently. Yeah, and so again, it's the device count. I'm pretty confident that we did have the right count, so I'm just going to go and leave 58. And then any other conflicts? No, it looks like that was it. Let's just take a look. So if we git add readme, git rebase continue, yes, the rebase is complete. And if we take a look and we see, basically all of this was to get this one commit out of those previous 13 commits. So That is really good. So let's go ahead and let's check out dev. So we switch over to the dev branch, and let's get rebase from this Nurzal device max. Oh, alert, problem. What is this? Another problem. Oh, with the README again. Okay. So now the problem with the README is still the count. Yes, the count. Blah, this is about the count. A 1, a 2, a 3. No Sesame Street fans out there? I learned more about life from watching Sesame Street and Mr. Rogers' Neighborhood. All right, so let's see if we add README and we get rebase continue, and we still have one more little problem in the makefile, of course. And let's see what that problem is. So that problem is we actually have several of the tests that were added to the smoke tests. We see that the Max 72XX, the DHT, and the keypad. So, and we want to leave those all in there, right? Not just the test for the DHT. So in this case, we want the current change. And then we see here that what happened was we added these 2 new devices to the list of regular Go tests to skip. So again, we want the current change. And so that's good. So now let's go back. And if we, let's just take a look and see our get status. It's taking a lot longer than I expected, but, you know, no biggie. So get diff shows us that it's the makefile that changed, but not the actual changes, because we are in the middle of a rebase. So if we well, once again, I made changes to the makefile, so I actually have to run the tests again. Otherwise, I won't know if it actually worked. So let's just go through this again, because we do not want to find out that our tests are broken when they break from our continuous integration server. Remember, that's there just as another line of defense, but shouldn't be our primary line of defense unless it's something that we have no other way of testing. So if you have some specialized hardware that you need to use for your tests, or rather, let me restate that. If your code requires some specialized hardware that you yourself do not possess, and you still want to run tests, you're going to have to run those tests in a different location than where you are right now. And so it may be your continuous integration server, or it may be something else. In TinyGo, we do that using TinyHCI, which is our hardware integration, continuous integration server that actually runs these tests against actual hardware devices. I talked about that in a previous stream, and when I'm done moving, maybe I'll be able to take some good video footage and show you a little bit more about how that works. So we're almost done running these tests here in the smoke test suite. And I'm pretty sure that will be the only thing we need to do in order to find out whether, in fact, everything's working the way we expect. Took a bit longer, but we have to do this right. There's quite a few people depending on the driver's repo for doing important things with sensors and displays to, show that information. So it's pretty important for us to take the time to do it right. In fact, that's generally been our approach towards TinyGo and all of the ancillary projects, is that, if you want software that can be relied upon, you need to spend a little extra time to make it that way. So since our contributors have spent the time to do this, we owe them and the rest of the community really the same in return. All right, we're almost done. There's quite a few of these tests. It takes a little while. It runs them each individually as opposed to running them all in parallel. So that might be one potential future optimization, but then we would have to write some code to determine whether that had happened. All right, so we've seen the test pass. So if we get add makefile and we get rebase continue again, and we have one last change. What is it? Oh, I should get add makefile. Let's see here. Get rebase continue. There were no changes. Let's see. It says, did you forget to get add? No, I definitely get added the makefile. I did that here. Then I went to get rebase continue, and it said that there were no changes. Oh, did I forget to save that file? That's totally possible. Let's go and take a look. I mean, maybe? All conflicts mix, run get rebase continue. But no, I say we get rebase. Well, actually, we can see what was the, there's nothing left to stage. Chances are that something else introduced the same changes. You might want to skip this patch. Okay, let's do that. So get rebase, skip. Okay, so now back to the README. We're almost done with this, I swear. And yet, once again, it's the count. I guess that's what happens when you have the conceit of wanting to have a manually generated count at the top of your README. You know, not that that's bad or anything. It's just, it means, we have to suffer through this occasional sort of extra text editing. Okay, so same thing, get rebase skip. And now we have a different problem. So let's see current patch to see the failed patch. And this is one of the patches that we added before to try to get the documentation correct. So I guess we better make that proper. We do know 58 is correct. So we'll get rid of that. Go down and probably the description also needs to be fixed. Yeah, here it is. And this is the same problem that we had before, right? That we thought we got rid of it, but we didn't, simply because we made too many changes all in one set of commits. And a bunch of them changed all the same files. So let's see what happened here. Get status. We have two changes here. So if we get makefile and readme, and then we get rebase continue, and we made it. And if we look at our list, we see that here is, where is that commit? Here is the commit that we were trying to get in here this entire time. Wow, that was kind of tough. All right, so now when I say git push origin dev, it's likely to fail because we've rewritten history, and we're going to probably have to force push. Let's see. Yes. All right, so if we git push origin dev -f, that will force the commits that we've rewritten, because we got rid of some commits and we added some commits. So now we go back to our dev branch. We'll see, hopefully, 58 devices. And we also see in our list of commits that it should match what we were just looking at a few moments ago, which we see, yes, there it is. And we'll go back to, it's running our tests in our dev branch using the Circle CI server. And let's go take a look and just see what it's doing over there. So this actually could take a little while because it has to pull down the latest Docker image that contains our latest TinyGo dev changes. So we'll just let it go on and do that because I want to switch over to something else entirely. Um, but that was very cool, and there's all thank you very much for that contribution. Oh wait, there is a problem. Wah. The problem here is that we did not run the go make format check, and in fact, there was some poorly formatted code. So we're going to have to fix that because we can't just allow that. So let's see where would that be? It'd be in one of the files that we just changed, and not the README, of course. But oh wait, where's this coming from? Uh-oh. Did we just wipe out our make file with some bad things? Let's go take a look. Suddenly I'm worried. I have a feeling I may have made an error. Let's go and take a look. And no, it's not in there. Maybe it's just... I think I should close without saving, because that may have just gotten... I may have hit undo or something. So, all right. What we were going to do is we just wanted to run Go format. So what is Go format? So Go format is a program that, if we say Go help format, then the Go format command actually goes and reformats all our Go code. And it does so in a way that allows us to make sure that Go code is always formatted exactly the same, right? Because that's what we want. Go says code should be formatted one particular way and no other way. And so some people who write in other programming languages think, wow, that's kind of like intense. You mean I can't just format the code however I want to format the code? What about my freedom, man? No. Let me explain. So within constraints, sometimes lies freedom. You need a little bit of discipline because then in one area, and it lets you have the freedom in another area. Here's a good example. If you have the discipline to get up very early in the morning because you want to work out or study the works of Carl Jung, and you don't have time to do this at any other time, you will have the freedom to do that if you have the discipline to wake up early. So how does this apply? That a lot of times the programming teams will get into long conversations about how to format the code. Should we have a squiggle bracket and then a new line? Or should we have a new line and then a squiggle bracket? So the designers of Go basically said, we're not going to allow that. It really thinks that the make file has got this problem. Let me go back and pull. If I say git pull, pull rebase origin dev, it's up to date. So I feel like something is not good. I'm going to restart my editor because I do not want to accidentally overwrite changes that are perfectly fine with changes that we just went through a bunch of effort in order to add. So let's go into the make file here just to make sure that we didn't accidentally do something. It still thinks that something's weird here. I mean, I want to see this in a regular text editor. So let's say more makefile. And yes, okay, the editor did not lie. That stuff is in there. That is bad. Let's go fix that. Whoops, I got a little too excited apparently when I was making those changes. So it looks like it's the current change that we need. Yep, That's it. And let's go and take a look at it was the code that was just added for the Max 72, I think, that maybe has some Git formatting problem. So if we just go in and save with my editor, then we can see, if I just run go format on maybe either one of those, it didn't tell us which was the file, did it? Let's go and let's see which file it was that's actually giving the problem. Let's see. So go help format will tell us that if we use the N flag, and we want to say, so we want to say go format, and we want to do basically all of the files everywhere. And let's say -N, so we see what they would be before they actually are doing them. So there's two, it's actually a totally different example that has leading dash. So if we git format and we just go ahead and change it, you'll see that we now have that file actually changed. So we have two problems that we had to fix, right? The first one was my merge conflict error that I inserted into the makefile, and the second one was this git formatting problem. All right, that was apparently somehow snuck into the examples there. So let's do this in two steps. First, we're going to add makefile, and we'll git commit, and we'll say build correct error in makefile from invalid merge. Did not expect to get into this today, but you know, what are you going to do? And then we have this other example where it was failing, so we're going to have to say git add examples, and we're going to say git commit examples, and then correct git format, go format error. So now we've made a bunch of changes to the dev branch, and I don't really feel like just pushing them without testing them first after the problems we've already made. So let's go ahead and say git checkout -b check fixes, and now let's go ahead and git push origin check fixes. So this will push this branch, which is the same as our dev branch, to a check fixes branch, and that way I can go back into the driver's repo. It will tell us that there's a new branch that just had pushes, and we can go and check to see, are these tests actually going to pass now, because we don't want to merge to the dev branch until we make sure they pass. That before apparently was a little bit premature on my part. I ran make smoke test, but I did not run the other tests as well. So the smoke test passed, but the other tests would have failed. So even I got ahead of myself. See, you must be cautious. You must be careful. Bad things can happen. Usually the bad things happen on like a Friday night, and then you push the code to production, and then you leave. Oh wait, it's Friday night here in Spain right now. I didn't want to be that guy again. I've been that guy before. I'll probably be that guy again, but not tonight. Not tonight, my friends. Tonight, we're going to at least have everything green before we, hang up our hats and move on to the next thing. Tempting as it is. So it's going to run those smoke tests, and then that probably is going to take about the same amount of time on Circle CI as it did on my local machine, because we're using the free plan. So Circle CI, if you're listening out there, Please, we'd love to have some compute cycles for running our tests in a more parallel mode. Do get in touch. And also, we'd like to be running GPU tests, which we'll talk about here right now while we wait for this to pass, because I'm pretty sure this is going to, well, no, we got to be disciplined. Let's wait. Tempting as it is to move on, we're going to wait until the test pass before we declare victory, just because that's what you got to do. I know. You're like, I got to go. My friends are in a bar. No, well, not these days. No one's in a bar. Fine. My friends are on a Zoom call waiting for me to get there. Yeah, maybe that's it. Nobody's really going anywhere at the moment. Not far, not fast. But hopefully that will end soon. And I look forward to seeing you all in real life and giving you some cool hardware. Because I have a lot of hardware, and I haven't had anyone to give it to since I haven't been able to go to conferences. You know, this stuff is kind of building up. It's backing up, you know, filling up all my space. So hopefully conferences will resume again this summer, and I can go back to giving some cool stuff away. In the meantime, you're welcome to come to Asturias here at La Pipa, as long as you follow all of the proper protocols, which may not allow you to actually travel here. But if you make it, I will give you some cool toys. Guaranteed. I have plenty. So we're almost done with the test here. I just want to make sure that it's passing, because other people will want to commit to this repo, and if I have not actually made it so it works, they won't be able to, and they'll be sad. And we don't want sad contributors, do we? So it's running the smoke tests. Then after that, we have a few more tests. We can actually go and take a look and see. I believe it runs the, actually I think it already ran the formatting test first, didn't it? Yeah, the format test already passed. The unit tests, which are the ones where it's executing our interfaces instead of calling TinyGo to execute the builds, it's using regular Go and interfaces to try those tests, and then our build tests. And you'll see, yes, we are all green. Success. All right. So now if we check out dev again, because remember, this was the same branch as dev, and we get push origin dev. Because remember, that's the same exact branch as dev. We just pushed it over there to a different name in case I didn't want to just keep breaking the dev branch over and over, which I had been doing up till that point. And we can make sure that's the case by going back to the dev branch here. And we see correct Go format error. That was the last commit. So I'm going to go and I'm going to remove that check fixes branch, since we don't actually need it now. Because you see, they both have the same number of commits pending, and both behind and ahead of the release branch. And so, cool, we did it. Success. Wow, that really took a lot longer than I expected. Sorry about that, but sometimes this is what we got to do. All right, so let's jump over now to something else entirely. So I do a lot of work in computer vision, some of you know. And in fact, I have a whole nother project that I'm one of the maintainers of called GoCV. So GoCV is a computer vision project that is a Go language wrapper around the OpenCV framework for computer vision. So if you don't know about OpenCV, it is it is by far the most mature of open source computer vision platforms, tools, frameworks. It literally has hundreds of patent-free algorithms for computer vision, as well as a few in the non-free part of the OpenCV contrib repo, where if you want to use those, you may need to obtain some licensing or whatever. So GoCV is a wrapper for the Go programming language around OpenCV. It's been around for a couple of years. It's got quite a few users, and I actually use it a lot for client work, doing computer vision systems for things like quality control, previous in retail. So recently, we have been adding to GoCV a set of capabilities that use what's called CUDA. So CUDA is a library for using GPUs for hardware acceleration in order to do highly optimized mathematical operations. For example, if you want to do a Gaussian filter, which is a very typical kind of blurring filter that if you use Microsoft Teams and you've used the feature where it will blur your background, that's a Gaussian filter. So if you want to run a Gaussian filter, generally speaking, it takes a while to process the data because it has to go through and perform what's called a convolution or a mathematical operation on each of the different sections of pixels that are next to each other in order to blur them all. So if you want to do something like that very quickly, you'll want to use your graphics processing unit or your GPU, which is actually an entirely separate kind of processor that you may have originally seen when you were trying to play the latest game, or more recently, some of you out there doing cryptocurrency mining, you bad people. So some of us need GPUs for computer vision. Anyway, that segues very nicely to what is going on right now in the GoCV project. So GoCV, we have been adding the capabilities so that you can use CUDA, hardware acceleration, from your Go programs that do computer vision with GoCV. This is something that has been a part of OpenCV for a while, but it is not something that we have done too much with. Up until fairly recently, a couple of our contributors really got the ball rolling by adding the initial capabilities for a couple of the CUDA functions. And so we have a new, how would I call it, little game, proposal, thing we would like you to do. Initiative makes it sound so formal. So thing we'd like you to do, that describes it well, but maybe too many words. So this month coming up, between now and the end of April, we need your help because we want to add a lot more CUDA features to GoCV. Because if you do hardware acceleration with a GPU, you're going to need to coordinate that work somehow with your CPU. And what better way to achieve concurrency than our favorite programming language, Go? So, it's just a match that's made to happen. So we've been working on, first of all, adding the list of all of the different CUDA features in our dev branch. If you just follow this link here that's on this blog post that we published just recently, like yesterday. So if you take a look and in our contributing guide, we tell you how to do it. And here we've got our roadmap that we've updated. So this roadmap here is a list of all of the different areas within OpenCV's CUDA features. And if you click on the link, it will take you to the documentation in OpenCV for that feature. In this case, it's a function called convertFP16 that converts an array to half precision floating numbers. So those are floating point numbers that are only half precision. That way you can do a lot more calculations with a smaller amount of memory if your accuracy is not quite as important. It's very commonly used when you're doing deep neural networks with computer vision. So if we do that type of conversion with the GPU, it'll be a lot faster. So you see that this is not yet implemented. There's no check. This is one of the functions that is implemented already in GoCV. It is the get CUDA enabled device count, which if you have multiple GPUs in your machine, if you're lucky enough to have a GPU at all these days, but if you have multiple GPUs, then this would give you the count of those. So we have here listed out all of the different functions that have CUDA implementations, and the ones that have already been implemented have a check mark next to them, And the ones that need you to work on it do not have a check mark. Can you see where this is going? So if you go and you add one of these features, not only will you have the endless gratitude of a community of Go programmers who can now do insanely fast hardware acceleration, but also we will send you a sticker. Yes, one of these really awesome GoCV stickers that you will be able to put onto your machine or your flight case or your notebook, any place, or just hang on to it for posterity's sake, and you'll be one of the awesome, proud contributors to GoCV's hardware acceleration, right? That's pretty cool. But wait, there's more. So let's say you add that first one, and now you've got a taste for writing Go code that can actually talk to extremely parallel hardware accelerated code. I mean, I'm getting shivers. I've got goosebumps. Like, I don't want to try to focus the camera, but I'm getting shivers just talking about it because it's just so incredibly cool. Also, it's incredibly fast. But so you've implemented one, you've added the code, you've added a smoke test to GoCV to make sure that we're actually exercising it, and you want to go further. Go and do another one. Do a third. At the end of April, whoever it is out in the wild worlds of the internet, whoever it is who has added the most features, the most missing functions to the GoCV CUDA support, we will send you an NVIDIA Jetson Nano developer kit, which is a very cool small form factor computer that actually has a built-in GPU. So it's like a Raspberry Pi if it had a GPU. Wow. Yeah, you need one of these, right? So you can get it. Just help us, help you, help us, help you. That's all you got to do. So if you go to the gocv.io blog, you'll see the post that talks about CUDA we do it. Yes, we can. It was actually going to be CUDA you do it, but then I realized, this was a group effort. So it would be better if we did it all together. So looking forward to reviewing your pull requests here in GoCV. So there's a lot of cool things you can do with GoCV right now, actually. And I was taking a look at some of them earlier. And one of the things that I forgot about was, so GoCV has got some cool example programs, basically not comprehensive examples, but actually added a lot of interesting features specifically to this CUDA initiative. It's like the Avengers initiative, but with computer vision and GPUs. So one of the things that we've been working on adding is some Docker images, which will allow you to exercise all of this within Docker without having to do a lot of crazy installation work on your own local machine if it turns out you're already using OpenCV and you don't want to have to try to recompile it with the CUDA support. So we have a Docker image. It's on Docker Hub already. We actually have a couple of GoCV Docker images that we created. This is probably worth mentioning just because, there you are. You want to use some of this stuff and you don't want to spend like 5 hours to, compile it. So let's see. I'm in the organizations called GoCV, and let's log in. And under the GoCV, we have a couple of Docker Hub repos, and they're all here listed under OpenCV. So these are pre-built Docker images that contain some of the more painful to build parts of OpenCV. So here we have OpenCV itself, the latest version. We have OpenCV, the latest version with GPU support using CUDA 10, which was the previous version, and then this latest build, which is a separate Docker image with OpenCV 451 and the CUDA support with CUDA 11.2, which is the very latest release. So if you want to use GoCV with CUDA acceleration and your, 3090 board, this is what you need. Yes. Oh man, I'm getting goosebumps again just thinking that much acceleration. What could we do? Oh my gosh, we could do so many things. All right. So anyway, did a lot of work on basically making sure that the features were going to be there for you to take advantage of. And so you can use this pre-existing CUDA image. And also, actually, let's take a look real quick. This will be helpful to you if you decide to take this mission, which of course you will, just because, you need this mission. You definitely need this mission, right? So let's see here. Where was my, oh, right. In the dev branch that I was just showing you the Docker file. So we also have a test file because this way you would like to run the tests. And you're wondering, so how do I actually run the tests in Docker against this code I've just written? Well, don't worry, we've got you covered. This is the Docker file that will exercise by running go test using the CUDA tests in that subdirectory in the GoCV project, which is where everything that you're going to want to be doing will be located. Remember, in the dev branch in this CUDA subdirectory, and you could see that, for example, I just added some of the things that were needed for the Huff lines, and Canny detectors. So if we take a look at the Canny detector, for example, we see we're loading a file from a JPEG from disk. We create a new GPU mat, which is an OpenCV matrix, but located in the GPU's memory. We upload, which means copy the data from the CPU controlled memory to the GPU memory. We create our new detector, and then we detect all of this happening, by the way, inside the GPU. Then we create a new destination mat, and we download the data from the GPU's memory back into the CPU accessible memory, and that's what we use for our tests. I mean, tell me this is not just insanely cool, and that you totally want to do this. You definitely should be doing this, right? Anyway, so CUDA is for Yuda. All right, bad pun? Yes, very, very bad pun. So I see ASW 101, who is teammates with Eric St. Martin, friend Eric, awesome human being, contributor to many open source projects, and one of the organizers of GopherCon. And apparently, so he recently did a series of streams. Actually, he's been doing a bunch of streams, wrapping up with some NVIDIA engineers. Oh, yeah, I'll definitely check out that last one. I did not see that. But yeah, NVIDIA is doing a lot of cool things over there. My friend Rex St. John is now at NVIDIA, where he had previously been working with ARM, which, as you may know, is owned by NVIDIA. So, it's all coming together, man. It's all coming together. Oh, so exciting. All we need is your help to add a bunch of these missing features, which, as you can tell, there's quite a few of them. I mean, there's quite a few already implemented, but a lot more to go. So, anyway, that tells you what we want on the computer vision front. There is so much to be done with computer vision on edge devices, by which I mean actual edge devices, drones, robots, safety devices like medical equipment, factory equipment where the processing of whatever is being manufactured is happening too quickly for cloud computing to be able to keep up. And then the other side, but we could do a lot of really interesting cloud computation, by using GPU acceleration. We can support multiple GPUs, not at the same time. So the CUDA support does not currently allow you to parallelize which is to take a piece of work and split it up across multiple different GPUs. Currently, it allows you to execute some algorithms on one GPU and then get back those results. But if you are a Go programmer and you have done any playing around with channels and the kind of concurrency that we can do in Go, and then if we do want to parallelize it, we could parallelize it using weight groups or other types of some of the synchronization primitives combined with channels. We could do some pretty interesting parallelization combined with these GPUs in order to execute them at really high speed. Now we're talking. So was not able to bring in my machine with a GPU for today. Plus, I would have gotten stuck anyway because I spent so much time on merging the TinyGo drivers pull request. But I will either bring in or do a remote connection sometime coming up in the next couple of weeks so that I can show you how easy it is really to add a new feature to the CUDA support in GoCV, and then we'll test it out and execute it and make sure it actually works, because that's the only way I'm going to get a sticker. All right, so we did a lot of cool stuff today. We didn't get to some of the stuff I wanted to do. My friend Lorenzo brought one of his ESP32 boards, but I didn't even have a chance to get to it, and we only have just a little bit of time left. So I'm not sure I actually have time to do that, because I wanted to show you a demo of GoCV doing something interesting. So, and combining together all of the stuff into one demo is what makes my life complete. So if we go and we take a look at one of the demos that is in here, there's a face detect demo. So this uses a Cascade classifier class. So it's not using a deep neural network. It's using a more traditional style of algorithmic computer vision. And but where is that file for the classifier? Okay, so I should be able to run the program if I run just this code right here. And it should use my camera that's built into my computer. Whoop, didn't mean to do that. There we go. So it should run the camera that's just in the computer. It should compile the code and then use this HAR Cascade face identification. Once it compiles and it runs, it should bring up the camera that's in my laptop. And then from there, we should be able to see my face, hopefully. Or will we? It's taking a little while to compile just because I actually switched over to a new build of Go. And so the GoCV, because it has a lot of C code, it needs to run both the Go compiler and it also needs to run the CGO compilers. So it has to do quite a lot of work until it starts to cache some of these things. So, okay, it's starting to read the device, and there we go. So you can see if I increase the size of this window, but let's not do that. Let's do something more fun. Let's plug in the drone. So I brought my drone, and I also brought, so I've got my little Bluetooth drone that I brought before, and it's got its camera. And I brought the adapter that we generally use for these things, which is your typical first-person video type of 5.8 gigahertz analog signal. So if I plug that in just to my USB hub here, it should become camera 2, or camera 1, I should say. And so now if I go and I change my program, so instead of using camera 0, that it's camera 1, we should, cannot open camera. Let's see. Did I plug it in properly? It looks like it is, but one never knows. Oh, I will plug it in directly to the adapter because maybe it doesn't like the hub. That seems like a definite possibility. And then if we go back to the Linux desktop, no, it does not see the camera for some reason. Usually it's the cable. Usually it's the cable, but not always. It may be just that it... Let's take a look here. Is it plugged in well enough? Yeah, it seems like. I have too many adapters on this cable, possibly. There is no light or anything, so it's hard to tell if it's working. But you know... Okay, no. Sorry, no. Okay, that was not what I wanted to have happen here. Yes, I did not get a chance to test it before I got here today to the studio at La Pipa. But naturally, if I test everything before I show it, it takes away a lot of the fun. Usually this happens because the little radio frequency receiver is not actually receiving power. Because there's not that much that can go wrong with these. But let's take a look and see in our last few moments, if under dev video, oh, we have a few video, oh, it's probably 3. Maybe. Oh, let's find out. Nope, cannot open it. 0 was the camera that's in my laptop. 1, it doesn't see, but it claims that there's these other videos. Video 0, 1, 2, and 3, which normally in Linux video would be, well, let's see. Because every time I unplug and replug it, does a new one appear? Oh, wait. Yeah, videos 2 and 3. Seems like it's getting a little confused. I wonder if I have something I need to configure properly that I do not have set on this camera. I have not used this video input for quite some time. Video 1 is there. No, cannot open camera by index. Let's try 2. Oh, yes, it was 2. Okay, so now we got the drone, and you can see, let's open up that window. So you can see that this is the drone's eye view. So now I am going to plug in my little power controller that I have been using for my flying the drone. And then we just need to get some power to this thing from a battery, which I will use the battery that GopherBot normally uses, because GopherBot won't mind. GopherBot's very cooperative. And we should be connecting to the drone. And if we are able to do so, we'll go for a little flight. Okay, here we go. Take off. Whoop. Oh. No biggie, I have the joystick reversed. You could see one of our guitars over there, and that was the end. All right, well, that's all we got for you today, my beautiful peoples. It's been awesome. It's been incredible. And it's been another day of fun hacking with Dead Program here at La Pipa.
Computer Liste, Computer everybody get flat. Computer Liste, Computer Computer Liste, Computer everybody get flat. Computer, computer. Computer,